happened. It's never done that before, but every single week something new happens and we learn about it and then we fix it for the next time. So we will do the best we can.
Yeah.
For you that don't know, I'm Miss Laura. I'm your education manager over at the South Carolina State Museum. We are, in fact, in Columbia, South Carolina. We know that some of our friends are coming to us from various places, not just around the country, but apparently around the world as well. So we are very happy and glad to see everyone. This is our weekly telescope live stream from the observatory. Mr. Matthew is in the observatory right now, and he's been running around and setting up the telescope so that we can look at some really cool things in the night sky. So thank you all for spending your Saturday night with us. We really appreciate it. If you hear any weird sounds, it's either the two dogs or the baby in the back getting ready for bed. So I'm at home, he's in the telescope gallery. We're just kind of doing everything every which way we can. We really appreciate you being here. We want to thank our members, as always, for supporting us. We could never do this without you, especially during these times. Without member support, we would be nowhere. And we would also like to thank Boeing for their constant support of all of our awesome astronomy content and the beautiful and amazing Boeing Observatory. So thank you to all of you for your support. Tonight is pretty cool. We will be looking at my favorite planet, which is Uranus, or Uranus, if you are trying to not make too many jokes. We have to be honest with you. All of us love Uranus jokes. We think it's hilarious. It's a common thing. So anybody at home that's just like, yeah, we're like that too. Anybody that's got any good puns, as long as they're clean, you can type them in the chat. We like a good planetary pun. It doesn't even have to be a Uranus one. It can be anything. Just make sure it's clean in the chat. And then we'll be looking at a live shot of Uranus. Some of you will be talking about Uranus's moons. The gas giant versus ice giant thing confused people the last time that we were here. So we're going to try and cover that again and go over that a little bit more, because that was something that people had questions about. And then maybe talking a little bit about lights and like wavelengths of light and how we get pictures of different planets as well. So don't forget to type your favorite planet in the chat. Mine is Uranus, and I will tell you that my favorite is Uranus because I think I just, like, when I was a kid, I was like, that's probably the planet that might get picked at the most, and I didn't like it. It really bothered me. I didn't want it to be alone and picked at because it's kind of a funny planet. It's tipped kind of funny. It's, you know, rotating funny. It's made of a bunch of methane, which is just like a bunch of cow farts. So I was like, I bet you it's a really lonely planet. So it quickly became my favorite planet, because if nobody else liked it, I was going to give it some love. So that's why it is my favorite. But we've got a lot of different people commenting in the chat already, Mr. Matthew. If you guys don't know, and if you haven't been with us before, we always start out with me yakking a lot, and then we'll go to Mr. Matthew and the real astronomers, and I'll start asking them questions. I take your comments and your questions on Facebook. I've got a couple of different screens up. I'm constantly writing and taking notes and stuff. So if you have a question or a comment, leave it in the chat on Facebook. All we ask is that you keep everything kind and courteous in the chat. That is our rule and our number one request. Keep it kind and courteous in the chat. If you have anything you're curious about, we'll either answer it in the chat. You'll know that I've gotten your question because I'll give you a thumbs up. If you don't give a thumbs up, it might not have come through. And if we can't answer it on air, we usually leave our email address in there. That way you can ask us later, just in case something happens. So let me see some of our favorite planets. Let's read some of those out. Saturn. Saturn is usually the favorite planet for most people. I think Saturn's the number one. Let's see, we've got people watching from Lexington, from Florence County. Hey, in Florence. Oh, the Graveses, they just were watching the ISS Passover. So good evening. Some other folks were watching the ISS. Venus. Venus is a wonderful planet. Another for Saturn or Neptune. I know Miss Liz's favorite is Neptune. Mr. Matthew, what's your favorite planet?
You know, I think my favorite planet's Mercury. Because
why is that?
I love the way Mercury looks in the sky, those times when you can see it. It's just really close to the horizon. You kind of have to tease it out. It's tricky, but once you find it, it's so pretty. So yeah, I like that.
That's a really good one. I like that. Not many people say Mercury. Mercury doesn't get a lot of love either. So I'm glad you love it very, very much. All right, and let's see. Oh, their Astro Kids, the Graves is that's one of our Astro Kids families. They all love Saturn. Some other folks like Jupiter. Very cool. The Graves has had a question about AstroKids moving the telescope. I told them to go ahead and email us because that might be something that we work into, like an AstroKid night or an AstroKid day, something specific for our AstroKids. If you are watching us and you have no idea what I'm talking about, we do have memberships at the museum. But then we have an add-on to one of those memberships, which is our AstroKid program. And it is for all of our young astronomers out there. They can do different activities. It's kind of difficult right now during COVID. We're trying to figure out the best way to go about this and everything, but definitely something to email us about. That way we can look into it. Let's see if there are any other questions immediately. How can AstroKids move the telescope? I think there was one more that I wanted. I wanted to check in with you. Oh, yes, Mr. Matthew, before we get started, common question that we often get did pop up again. Can we see meteors through the telescope, or a meteor shower through the telescope?
Okay, so meteors go very fast in the sky. And because they move so quickly, you actually can't really see them in the telescope. If we could somehow get a telescope to catch a meteor, we'd see it just flash by in the eyepiece. It'd be like, whoa! So yeah, telescopes aren't the best things for meteors. The best way to go find meteors is to go outside with a nice comfy lawn chair and a blanket, especially on a cold night like tonight, and just lie back and look up at the sky. And usually you'll see maybe a couple of meteors at least an hour.
Very, very good tip. All right, folks. So I'm going to go ahead and pass it over to Mr. Matthew. If you have any questions, type them in the chat. Every once in a while, you'll hear us ask you a question, and you type those questions in the chat on Facebook as well. Please be aware that there is about a 20-second delay from when we ask a question to when we're going to get it back on the air. So just be patient with us because it takes a little while for all these things to loop around. And I think that's it. All right, Mr. Matthew, it's all yours.
All right. Well, before we get started with Uranus, I wanted to show you all a really cool bit of news. So every week at the beginning of our program, I like to spotlight some of the things that are going on in the observatory or some things that are going on in the news. We're just in the observatory getting our distance learning and virtual field trips ramped up. We had 2 this week. Next week we have a bunch, and then the next week we have a whole bunch. So that's all starting to ramp up. But in the meantime, I have some cool news to show you, and this kind of links into that theme we talked about of light and wavelengths. So I want to make this big. What is this? What does everyone think this is? Does anyone have any just wild guesses? I'd love to know what some of the guesses are in the chat.
All right, so in the chat, type in really quick, what do you think Mr. Matthew is showing us on the screen? While he starts to explain it, we'll go ahead and get some of those answers in.
Let's see, we'll give it just a second. Are we getting some answers yet, or are we still on the delay?
It takes about 20 seconds for us to get some answers in.
I'm just curious to see what some of the answers are.
Well, let's start describing maybe what we see first, because it's awfully shiny.
It's awfully shiny. Yeah.
There's a lot of people around it, but they look very tiny compared to it.
So it's very big, and you have all these people in lab coats, and they've got hoods on.
Oh,
and it looks like it's in a very big room. Do we have some ideas as to what this is?
No, it takes about 20 seconds or so, like 20 solid seconds.
So this is, I wouldn't actually expect you all to really know what this was.
Ooh.
I was curious. Yeah, let's see if we get anything.
We got 2 in. So the Graves family is saying a space sail, and then some random person named Ava Bouquers, we don't know her very well. She's one of our dear staff, says rocket parts.
Rocket parts and a space sail. So on this program, we talk a lot about telescopes. And one of the telescopes we talk about all the time is the Hubble Space Telescope. One of the pictures I'm going to show you of Uranus tonight was from the Hubble Space Telescope. We also talk about the James Webb Space Telescope. All right, let's see, what else do we have?
Abby says it looks like a shiny coffin, which is very true. And Adina says it looks like a solar sail.
Solar sail. All right, so this is actually the sun shield for the Hubble Space Telescope's successor, the James Webb Space Telescope. So we talk about Hubble a bunch. The James Webb Space Telescope is a much bigger telescope than Hubble that has been in development for the past, oh gosh, who knows how long. Its launch keeps getting delayed. It's now scheduled for launch on October 31st of this year, so we hope it actually does go up and does not get delayed again. But what this is the sun shield for the James Webb Space Telescope. It was deployed just within the past few weeks for the first time. So this is a really critical part of the telescope because what this does is blocks sunlight and heat from the sun from the telescope. So the telescope can see things that are way off in space. So we're talking a little bit about wavelengths and light this evening. So we have visible light, that's the light that your eyes see. We also have infrared light. This is a longer wavelength than visible light. And the James Webb Space Telescope is primarily going to be an infrared telescope. And for it to see these faint infrared signals from deep, deep into space, it has to block out the infrared radiation from the sun. And that's what this is going to do. Yes, do we have a question?
What is infrared?
What is infrared? So again, visible light is the light that you see with your eyes. Infrared light has a wavelength that's just a little bit longer. You can't see it with your eyes, but you can kind of feel it as heat. So you can think of it as heat. So this telescope is kind of like seeing heat signals in space.
So for all of our younger friends, what Mr. Matthew is saying is that light is on this really long spectrum, right? It's on a really long spectrum. And if it's about this long, if the light that we can see is about this long, the light, or what the spectrum is about this long, the light that you and I can see with our eyes without anything special is about this big. There's stuff out here and there's stuff out here. It's still part of the light spectrum, but we can't see it with our eyes. Our eyes aren't that advanced. They're not, well, advanced or not, because some insects can see those. So, and that includes things like infrared and ultraviolet. So, and it also includes things like when you take X-rays, we can't see in that wavelength. Ultraviolet, you might be familiar with because that's why you wear the sunscreen. And everybody, I'm Hispanic, I wear a lot of sunscreen. Doesn't matter how brown you are. We need to wear our sunscreen to protect our skin. So what Mr. Matthew is saying is that this is a wavelength of light outside of that spectrum that we can't see with our eyeballs, but that still exists out there. And if you use a special camera, you can see it then.
So what this telescope's going to do is use infrared light to look way, way off into distant parts of the universe, because it seems that when we look way off into the universe, there's something called redshift. So light actually gets stretched out as it travels through space. And if something's far away enough, it's possible for its light to get redshifted out of the visible spectrum and into the infrared spectrum. So this telescope's going to be looking for those types of faint signals. So this is really exciting because this shield was deployed for the first time. And the thing is once this telescope launches, unlike the Hubble Space Telescope, which we, at least when we had a space shuttle, we could go up and fix it if something broke, this telescope is going to be much further away from Earth. And if something breaks after it's launched, we can't fix it. So this heat shield right here had better deploy properly. So it's really important that we test it here on Earth to make sure it works right. Because once you get into space, if this thing does not deploy right, then the James Webb Space Telescope is permanently, and we don't want that.
Bad.
Bad, yeah, bad.
Because that's not just like a quick, oh, somebody run out and fix it real quick. We're not going to fix this really fast, right?
This is billions and billions of dollars, and probably actually, and then, we've been working on this telescope for, gosh, a few decades now.
Yeah.
A lot of work over a lot of time. down the drain. So,
oh, could you imagine doing that? If like one little tiny screw isn't in the right place and the whole thing falls apart. Could you imagine being that person? Like,
it's a sun shield, they're trying to expand it, and then it kind of like locks partially expanded. It's like, oops, darn. Okay. Well, do we want to have do we have a question?
yeah, Miss Ava's wondering how, or I'm assuming Miss Ava and maybe her boys are wondering how many panels are going to be used on this.
I'm not sure how many panels there are. I think we're seeing all the panels right here. So it's like, what, 4, 5?
4 or 5?
Yeah.
1, 2, 3.
The telescope structure actually kind of sits on top of this whole thing. So you're not seeing the telescope structure here. It's not on yet. But the telescope will sit on top of this thing.
Do you happen to know what kind of material the sails are made out of?
I don't. I just found out about this like right before this program. So that's something I'll look up and we can mention that next week.
Yeah,
and then in a couple weeks, we have a whole program we're going to do on telescopes and how they're made and all of that kind of cool stuff. So we're going to have that coming up soon.
Awesome. I know I'm really excited about that. Y'all, Mr. Matthew has been like super excited to do that program in particular.
Yeah. So now I just want us to take a quick look, hopefully here at Uranus. Hopefully the dome hasn't gotten in the way. We're going to find out here in just a second. Up. It looks like I need to go, and well, I might be able to do this from here. I'm going to show you a live view of Uranus before we actually take a picture of it. We're going to take a picture of it at the end. It looks like my camera has timed out. Okay, just a second. Let me go see if the dome is in the way. I'm going to try to show you Uranus here in a live view, but it's really, really hard. So let me go see if the dome is blocking the view. I actually can't see it right now. So I'm gonna go see if we've got the dome in the way. So give me a second.
Okay. While you're doing that, I'm going to respond to David. David's asking, what I thought we were looking at Uranus and things to do with Uranus. What does this solar thing have to do with anything? Every single week we cover an update. We good? We cover things that are happening now in astronomy, like something cool that happened. So sometimes it's something that our students have done during the distance learning. Sometimes it's something really cool that's happening and maybe something that NASA has done, a new image that has come out. Mr. Matthew just found that picture of the James Webb Space Telescope right before, and he thought that was really cool to share. So we always start off with like a little recap or an update of what cool things are happening now in astronomy, and then we go into our programs. Now, whenever we say possible topics, at the top of every program, you'll see a screen where we list what possible topics or subjects we could cover. And that we always say possible because things happen. If the telescope goes down, if we just can't get it through the clouds, if something really weird happens with our tech, we might have to switch up those subjects a little bit. So we always try to have multiple subjects that we could go over. That way we have different subjects to cover. So that is what that is. Hopefully that's a little helpful to you. I'm sorry if we disappointed you, but we are getting to Uranus now if he can get it into the telescope. So
this is Captain Matthew here off camera. It looks like the telescope actually, it was pointing at Uranus, but now it's not. So let's see if I can find Uranus again here.
Okay.
Goof telescope. All right. Let me go try that again.
You never know what's going to happen when you're not just when you're doing Zoom and trying to get to Facebook Live and you're doing tech, but then we throw in a giant telescope in another room and things just get crazy. So how many panels are used? Uranus is my favorite planet too. I know Mr. Matthews is Mercury, Miss Liz's is Neptune. Usually people like Saturn a lot, but I got to tell you, somebody said Earth earlier, and I always wonder, that is funny. I guess we should all kind of like Earth the most, right? We're kind of here, and she's taking care of us, so maybe we should love on Earth a little bit more. Everyone's favorite planet should be Earth first, and then we'll love a second planet. So I should start asking, what's your second favorite planet? Let's see. All right, Mr. Matthew, we got it. So if for those of you that have never been to our museum, the room that Mr. Matthew is coming from, that is our observatory classroom. And right behind him is a doorway and the actual telescope that he's using. So he actually has to run in and out between two different rooms to make this happen. He's working off of a giant screen. So he goes into a different room and he can't hear us right now. We could say all kinds of crazy things. All right, there he is.
And guess what? I found Uranus. I think the telescope had a little tracking issue. It's pointing in a position where sometimes that will happen. So I'm going to share my screen here. Let's see if I can find my Zoom window. There it is. Here we go. So here comes a view of the camera that's controlling or the computer that's controlling the camera, rather. And you can see we got a bunch of junk up here. Let's get rid of some of this junk. We don't need it. We do need, well, why are you not listening to me? Now, there it goes. So we don't need that junk. Don't need that junk. But we do need this. So this is a live video view from the camera. And right here, where my mouse is pointing, this little dot is Uranus. So can everyone see that little tiny dot?
I'm going to be honest with you, I cannot.
Yeah, so Uranus is about 2 billion miles from Earth. It's not quite that far, but it's almost 2 billion miles from Earth, and it doesn't look very big in our telescope. Now,
I really can't see.
Yeah. It's actually, it looks like just a little tiny speck. Can anyone see it? I'd be curious if anyone can see it in the chat.
So everyone in the chat, let us know if you can see it. If you're like me and you do all of your Facebook Lives on your cell phone, if you can see that, I guess, no, you can't Zoom.
Yeah, if you're watching on your phone, you probably won't be able to see this unless you have a magnifying glass.
I'm gonna be that person on Zoom that gets way too close to the camera.
Okay.
I can see it when I get real close. I can see it. Oh my goodness.
So that's our live view. Now we can actually get a better view.
Okay, I'm not crazy, Mr. Matthew. I got a lot of people saying they can't see it. You and me, guys. You and me. I can't see it.
You're not crazy at all if you can't see that. This is really tough. So we're actually using a fairly complicated camera setup using our big Nikon camera. And with this live view, we're actually kind of operating at the limit of the camera. So we're looking at about as faint an object as it can see in this live mode. But what we can do is I'm going to take it out of live view. I'm going to close this window down.
Okay, so it's going off of live view.
Off of live view, and we're going to take a time exposure now. We're going to take one of about say a 1/10 of a second.
Okay. Okay.
I'm setting our camera up to take a 1/10 of a second exposure. Now I'm going to click shoot. And I'm actually going to get us a better view than that. Should be this one right there. There we go.
Okay, I can see that. Now, some people, we do have a question. Someone's asking what the scope aperture is, and someone else asking, why can't you just expand the window and make the window bigger?
Yeah, so we're using our Clark telescope, which has a 12-inch lens. So this is our big telescope, the big gray one if you've ever been here. And for some reason, the camera software doesn't allow us to expand that live view. I don't know why, but it just wants it to be small. And really that live view is just kind of designed for you to find things in the camera and such. It's not really designed for you to actually take pictures with. So once we take a picture, we can actually get the big view. So here it is right here. There's Uranus in our telescope. And does anyone see a color? I'm just curious. Anyone see a color?
Interesting. On my phone, I cannot see a color, but on my screen, my bigger screen, I can see a color. So can anyone in Facebook world see a color? Yeah, you can see it. Good. I'm glad you can see it. Jupiter and Earth, Aiden, very good. I love Jupiter and Earth. I, of course, love Earth. Let's see, does anybody see a color? I do have a slight color on the screen. Mr. Matthew, can you move your mouse slightly away from it?
Yeah.
When you're looking on a smaller screen like your phone, the mouse is actually, the little pointer is actually a little over, yeah. All right, so Miss Angie says it looks like a grayish blue. That's the same color I'm getting on my screen, is like a grayish kind of turquoisey blue. A light blue, we've Shavari, I'm hoping I say that right, and if not, let me know, because you are definitely worth having your name known. Says light blue. Kevin says blue. Ava says blue. Hey, Miss Kate. Mwah. I know the girls are in bed, but say hi to them for me. Blue green, but she's on her phone. I know, me too. I think that might be all of. I'll let you know if we get more. Oh, Dot says, or Abby says it looks white on their screen. So those are some of the answers we're getting in.
Yeah, so on my big screen here at the museum, and I'm looking on this big touchscreen thing, big old thing, it looks kind of bluish green. So really, if you're seeing sort of bluish, grayish, whitish, greenish, that's about what you're going to see. I'm going to see if I can take another picture. I don't know what this is going to do, but I'm going to see if maybe if this makes the color a little easier to see. So we're going to take a little bit of a longer exposure. We're going to take like 1/5 of a second here. No, take that back. Let's take 1/2 of a second. Let's see if that helps to see the color a little more, or if it's just going to overexpose the camera and make it look, our Uranus look like a bunch of washed out junk.
Okay, all right.
Find out. Looks like washed out junk. Look at that.
No, but you can see the color a little bit more.
Let's see. Let me open the big version of that. Yeah, I'm not sure if we're seeing the color here or if we're seeing just junk in the camera or junk in the color.
Now, Mr. Matthew, one thing that I think, a question that I know that we get a lot is, well, if your telescope is so big and it has a hard time seeing it, will a smaller telescope even be worth it? So does the bigger the telescope necessarily mean the better the image every time?
So yes, in general, yes. And Uranus, though, remember, this is 2 billion miles away. So with a smaller telescope, you can still see it, but it's going to look fainter than it does in our telescope.
Okay.
Yeah. So this little dot kind of view is actually kind of how it looks with our telescope here. Even though we have a big telescope, we're looking at a really far away planet. And yeah, it's going to look kind of small.
The reason we don't just kind of hop over to this planet.
And also Uranus is frankly not that big a planet. It's only about 4 times the size of the Earth. So it's a little smaller than Jupiter and Saturn.
The Gatsons actually told us earlier that Uranus is the third largest planet. Thank you, Gatson boys.
Yes, it is. So I'm just curious. I want to take one more picture. Oops, I just turned off screen share. That's no good. Well, and now did I lose my splash top window? I think I did. Oh, well, I think we have seen enough of Uranus. I've got some more pictures of Uranus for you all for sure. All right.
We have a question coming from Wesley. He's asking, why are you using units like miles? It seems odd for a scientist to say miles.
So actually, I just happened to, while Miss Laura was talking, I looked up the distance to Uranus in miles very, very quickly on my phone because I was a very silly scientist. And I forgot to look up the distance to Uranus in kilometers before this program because I was actually looking up some other things in kilometers, which we'll talk about in just a minute. So silly me, I was looking up some things about Uranus's moons, but not about Uranus itself. So boom.
And a lot of times what we'll try to do for our younger students, because they're learning miles, we'll say kilometers and miles. So sometimes we can forget to say the kilometer because we're thinking, oh, don't forget to say the mile for the younger students. That way we make sure that they kind of have a slight grasp on what's going on. Although at the end of the day, when we start talking about these distances, it's so hard for me as an adult to imagine just how far that is. I can't imagine when you're really little and you've never driven, 80 miles. how to get that through your brain. It's just, it's a lot. It's a big.
Absolutely. Well, shall we take a closer look at Uranus in another type of instrument, maybe?
Absolutely. Absolutely. I would love to see these. I'm excited.
Let's actually see what Uranus really looks like. Okay, why is there's my screen share window. All right, we're gonna see our James Webb, our sun shield again here. But just a second, let me let all this load. Let's go to the next slide that I have. This right here is Uranus taken from the Voyager 2 spacecraft. Now, you notice that it has that kind of blue color. We did see that in the telescope. But look at how little there is in the way of surface detail. It just kind of looks like a blue circle.
Yeah, it kind of just, yeah, you can see some if you're on a computer screen, you can kind of see some what look like clouds maybe at the bottom, but it's really pretty smooth looking.
Well, check this one out now.
Oh, that's so.
So remember we were talking about the James Webb Space Telescope and we were talking about infrared light just a few minutes ago?
Yes.
This is Uranus in infrared.
That is so cool. Oh, I love that image. So yeah. What are we seeing? What are we looking at?
So Uranus in infrared from the Hubble Space Telescope. You can actually see the rings. You can see that Uranus is tipped on its side. So there's Uranus's axis, goes through like that. And then the bright areas are clouds. So the brighter the cloud area, the higher those clouds extend in the atmosphere. So these are a bunch of clouds right here. This is a cloud band right here. Mm-hmm. These areas that are kind of blue, these are areas where the atmosphere is more clear. And then we have a little dot here, and here, and here, here, and here. Does anyone have any idea what these are?
Ooh, Facebook question. So what do you think those little dots are? What do you think they are? So Wesley says that he thinks it must have been hit by something to make it tipped up over on its side like that.
Yeah, that's probably what happened. Something smacked into Uranus.
What are those bright, like reddish spots on the right side of it?
Yeah, so those bright reddish spots, those are some of those clouds. And these are areas where the clouds are extending high up into the atmosphere of Uranus.
And I've got a private message that's saying he keeps saying infrared. Does that mean the light spots are hot?
So they look brighter because they may be a little warmer than the area around them. They're not like hot, like the sun is hot.
They're just warmer. So when you're seeing infrared and you see something really bright red or bright white, it actually goes off the scale. It doesn't necessarily mean that it is hot, but it is a lot warmer than the things around it, sort of. Especially, it depends on a few things, but in general, that's the kind of simple idea.
We actually may need to do a program. This gives us an idea for a future program on infrared astronomy. And we can think if we can chase down our infrared camera, we can have lots of fun.
Oh yeah, I did a NASA course on that when I went to NSTA, and it was really cool when they were showing us some of that stuff. That would be really fun, and that's some at-home activities you can do too, because they showed us some apps on our phones, so we could show you guys at home how to do some of that too.
Yeah, so I think we might really need to do a program on different types of light and infrared light, infrared camera. Yeah, we'll put that in the plan.
Yeah, I like that. All right, so we do have some people chiming in, and they think those things are moons.
Mm. Well, that's exactly what they are. So Uranus has 27 moons. So this is the thing with our gas giant and ice giant planets, our outer planets, is they have a lot more moons than the inner planets. Jupiter has 79 moons. So Uranus doesn't have as many. But the thing about the moons of these outer planets is that they are absolutely fascinating. So for example, around Jupiter, we have the moon Europa, which has a liquid water ocean. Saturn has Titan, and Titan rains liquid methane on the surface. We have around Neptune, we talked about this several weeks ago, it was before Christmas. We talked about, this was kind of easy to get confused with Titan. We talked about Neptune's moon Triton, which has like ice volcanoes on it. So we're going to take ourselves on a little tour now of the 5 biggest moons of Uranus. Yes, do we have a question?
Nicholas would like to know, does Uranus have 16 rings?
I'm not sure how many rings Uranus has. Shall we look that up really quick?
Sure, if you think you can find it quick, yeah.
I can probably find it really quick here, and I have some notes on my phone, so I'm going to need it anyway. Uranus.
And Wesley has one of my favorite comments so far. Yes,
rings. According to the Googly, Uranus has 13 rings.
Oh, all right. I guess it kind of, yeah, I don't know.
So yeah, 13 rings. So you can kind of see them kind of tucked away in here. Remember, Uranus's rings are very faint. So they're really hard to see, very different from Saturn's rings. So, shall we go?
Yeah, I would love to see the moons. It sounds like a cool little solar system.
Okay, so we're going to go on a tour of the 5 largest moons. And here they are right here. This is Uranus. This is actually, there's 6 moons here. This little one right here we're not going to talk about. But these 5 moons are the ones we're going to talk about. We have Miranda, Ariel, Umbriel, Titania, and Oberon. So here is our question for the evening. What are these moons named for?
All right, everybody in Facebook world. So what are those moons named for?
Yes, what are those the names of? Like Miranda and Ariel, Titania. What are those?
Is it bedtime? Night night. Help you. All right, what do we think those moons are named after? Let's see. Slightly different subject area, Wesley. No longer talking about our MC universe anymore. We have switched to something slightly different, although I guess not totally, but yeah. Let's see. Anybody know what those moons are named after? It is Neptune after all.
All right.
All right, so we've got the Graves family saying daughters of Greek gods.
Okay.
Sarah Catherine's back with us. She says Shakespeare. Miss Dot says goddesses. Miss Dot, I think maybe that's coming from Abby, is saying goddesses. Okay, those are the few that we've gotten in so far. Let's see, any other ideas? While we're waiting for some of those ideas to come in, Sarah Catherine is wondering, she heard that Saturn lost a moon. Is that true?
I have no idea.
But we will find out for you. We'll try to mention it next week.
Although with that, we keep discovering things and it's like, is this a moon or is this part of the rings?
Is that what I was going to ask? Is that kind of what happens to Saturn sometimes? It has moons, but it has the rings are all really big too. Do they sometimes crash into each other and cause problems?
I don't think they crash into each other, but it's sort of like, what's a moon? What's a really tiny moon and what's a piece of a ring?
I gotcha. We have Shavari also saying angels, and then we've got the Gatsons saying goddesses as well. So those are the answers we've gotten.
Okay, well, hats off to Sarah Catherine, who mentioned Shakespeare. Not Neptune. Uranus's moons are named after characters from Shakespeare plays. And
that was me. I actually might have confused people. And so saying Uranus, I said Neptune instead of Uranus earlier. That's my fault. I misspoke, everybody. I'm sorry.
It's one of those ice giants, one of those outer planets. It's all good. So yeah, Uranus's moons are named after Shakespearean characters and also characters from Alexander Pope's poem, The Rape of the Lock. So we're kind of leaving astronomy here and going into English literature. And it's kind of fun to just go identify them. So I'm going to be showing you the moons here in order from smallest to largest. So is that Logan right there?
It is Logan. Something's happening outside. He's a little scared, so he's decided to snuggle on the couch.
Hey, Logan. Okay, so we have Miranda here. And these are Meteor 2 images. We don't actually have super great images of the moons of Uranus, because really the only thing that has gotten really close to them so far has been the Voyager 2 spacecraft. So Miranda is the smallest moon. It's about 500 kilometers across. And this is named after a character from The Tempest.
Wow, it's very beat up.
It is very beat up and very icy. So these big moons of Uranus are made out of ice and some rock. They're actually really similar to Pluto. They're very similar in the way they're made to Pluto. And in fact, if they were orbiting the sun instead of a planet, we actually might call these dwarf planets. Yeah. So there's our Miranda, the smallest. So now we're going to head off to Ariel. And again, kind of similar, this sort of cratered, icy thing. And Ariel, this is another character from The Tempest, but also Alexander Pope's The Rape of the Lock. And oops, I left off a parentheses there. Look at that. I can't type. So now let's go to the next moon, Umbriel, also from The Rape of the Lock by Alexander Pope. And again, just this sort of dark, cratered surface, icy surface. Now, this is one of the things that we see with Uranus's moons, is they're actually fairly dark bodies. They're not super bright. Now, Umbriel has a big crater right here. So you're seeing the walls of the crater right up here at the very tip top.
Oh, wow. Okay.
And then, a little more color here. This is Oberon. From a character from A Midsummer Night's Dream. Again, looks kind of similar, this sort of icy, cratered surface. And then we have one more, Titania, also from A Midsummer Night's Dream. And again, you see a lot of craters and icy kind of stuff. So I think the moons of Uranus aren't quite as cool as like the moons of Neptune and Saturn. We don't have Titan with ice volcanoes and such, but still, it's just kind of neat to see these moons of outer planets. They all have personalities, and they're actually scientists who make entire careers out of studying the moons around planets. So you're basically, when you study the moons around these planets, it's like you're studying worlds in and of themselves.
Yeah, I mean, they have to be made of such different materials and things. It's, oh my goodness. And so these are mostly ice, is that what you're saying?
Mostly ice with some rock thrown in. I think Miranda is almost completely ice.
Wow. Well, they're beautiful. They're very, and Miranda, it's especially look very, almost like carved in, like, when you were playing with, like some toys on Play-Doh or something.
So this is something that I learned as I was putting things together for this program, is the moons of Uranus. So we know how Uranus is tipped over.
Mm-hmm. Yeah.
The moons of Uranus, their axes are tipped over as well.
Oh, wow.
And apparently that means that depending on where you are on the planet, on the moon, actually, rather, not the planet, the moon, the sun will appear to kind of go in circles around the sky.
Oh my goodness. Around.
Yeah. Instead of rising and setting, it'll kind of go in circles around the sky. So yeah, just very different places from our own Earth. And these are right here in our solar system. So while, yeah, Uranus is about 2 billion miles away, that's not that far away. The nearest star is about 4 light years away. That's about 24 trillion miles away. Than the nearest star other than our sun. So yeah, kind of amazing.
Cool. Very cool. It is 7:45. So what other subjects are we going to cover in our last 15 minutes or so?
I was going to talk a little bit about ice giants. So we might, ice giants and gas giants First of all, I think since we really enjoyed that picture of Miranda, I'm going to bring Miranda back up here. And this is something that is tricky to explain. So if you're having a trouble understanding it, it's actually tricky to explain too. I think Liz, our planetary manager, does a beautiful job of explaining it. I actually pulled an article off of, I think, Science Daily, and I'm going to look that up here. And so I'm actually kind of looking at my phone to see this description because it's really well written. The cold and remote giant planets Uranus and Neptune are nicknamed the ice giants because their interiors are compositionally different from Jupiter and Saturn. So what the heck does that mean? So the inside of Uranus and Neptune is made out of different stuff than the insides of Jupiter and Saturn. So we're talking about the core, the inside part of the planet, the part of the planet that you can't see because it's deep down. So ice giants are also smaller. So Jupiter and Saturn are much larger planets than Uranus and Neptune. Yes, Uranus is the third largest planet, but I actually looked up some numbers. Uranus is about 50,000 kilometers in diameter. Jupiter is about 140,000 kilometers in diameter. So Jupiter's a lot bigger than even Uranus. And just for comparison, Earth is about 12,000 kilometers in diameter, or 8,000 miles. So let's go back to our lovely ice giant description. The ice giants are also much smaller, yep. And I love it, they represent the least explored category in our planet in our solar system, which is absolutely true. These are planets that we actually in some ways don't know that much about because they're way far out. So basically you can think of them, if you want to just think of the very basics of ice giant versus gas giant, again, Liz does a much better job explaining this. Basically, they're actually made of different stuff. So the insides are different, like Jupiter and Saturn have much more hydrogen and helium in their inside than Uranus and Neptune.
I gotcha. Okay.
Again, it's not an easy concept to understand.
But for our South Carolina students who might be tested on this, is there anything, are they incorrect when they say gas giant for those last 4 planets?
No, it's like if in general, it's okay to say gas giant for those 4 planets. So the gas giant versus ice giant thing that's sort of a subtle designation. The thing that often happens is when we talk about Uranus being an ice giant planet and Neptune being an ice giant planet is we think, well, that must mean that these planets are big chunks of ice. Actually, no. It refers to what they're made of. It refers especially to what their cores are made of. So that's where things get really confusing. This moon right here, Miranda, that we have up on the screen is a chunk of ice. Pluto is largely a chunk of ice.
Okay.
Uranus and Neptune are not chunks of ice, even though we call them ice giants.
I gotcha. So all 4 of them are of our outer planets. They are gas giants. However, Uranus and Neptune might have an icy core, so they are sometimes nicknamed ice giants.
It's not even really an icy core. It's just a core that's made out of different and heavier elements.
Okay.
Than Jupiter and Saturn. Again, gas giant versus ice giant. If you're struggling to wrap your mind around this, that's totally understandable. Don't feel bad. This is actually not a terribly easy concept to understand. So, do we have any questions that have popped up?
No questions. 10
minutes left. This is interesting. We actually have about 10 minutes left, and these are the main things I wanted to talk about. So thinking, what do we maybe want to do for the next few minutes? Do we want to take another look at Uranus in the telescope?
Sure, yeah. Do you think there's like a way that we can maybe see it bigger somehow?
Yeah, well, I'm going to need to reconnect the computers here. So this is going to take us, because we were going to take a longer exposure of Uranus. That's right. You're going to take a longer exposure of Uranus. So let me get set up to do this. This is actually going to take me just a second. Let's get rid of this window because I don't need it anymore. And I need to bring up splash top here. I'm actually making our computer here link up with the computer over in the observatory that's controlling the camera. So let's connect. And now, of course, I have to go put in a password. So let me go do that. Make sure the dome's in place, and then we'll start having a look again here at Uranus in the telescope. So give me just a second.
All right, sounds good. And if you guys have any questions or anything for us, if you have a subject area that you might want to know about on a future date, we try to line these up and we do some prep and planning about 4 weeks ahead of time. So we've got the next 4 weeks mapped out and we try to keep doing that. But, you know, if we come up with a subject like we did today during this live, what we'll do is that'll be our next week after that. And so we kind of keep adding them on. We base them around what everyone has questions about. So if you want to email me, you can. I'm happy to take emails and everything. But if you want to type it in the chat, that's fine too. We get to it and we will start kind of pulling things and making different subjects for future live streams. So please let us know what your questions are. Oh, Matthew, I will ask when Mr. Matthew comes back. The composition of the cores. I was a little curious about that too. I understand Ms. Liz did a wonderful job and does a wonderful job of explaining the difference. And I think at the end of the day, it's just they're gas giants. It's just that they're nicknamed ice giants because of what their core might be kind of composed of. But so it's a little bit of semantics, I think. But yeah, for our students, it's okay to say gas giant. It's definitely all right. If you're a student and you're saying gas giant and you're tested, gas giant is okay. Let's see. Perfect planet for Elsa. You're right. You are very correct. Elsa would like it on one of those frozen icy places. And how do they determine it? Yeah, I'll ask him when he comes back. That's a good question. Rings make moons. Very cool. Very good. Hey, Mr. Matthew, we do have a couple of questions.
Okay, and then I remember that I was going to talk about something that I am leaving out. So we'll talk about that really quick. But what are our questions?
So how do they know the composition of those planets' cores and how do they determine that?
So there are various ways we can figure out what really anything in space is made out of, whether it's a planet or a star. One major way we do that is we take a spectrum. So we take the light from an object and we split it up into all of its colors, like the colors of a rainbow. And I think, oh, there's Holly. This is Holly, right?
There's Holly, yeah. There are fireworks outside, so both dogs are a little scared.
Oh, yeah. Oh. So, yeah. So if we take the spectrum of light from a planet or a star, that can tell us what's inside of it. So that's one of the big ways that we figure out what something's made out of. Another thing that actually astronomers will do as they're trying to figure out these planets and how they work, especially inside, is they might not use a telescope at all, but they might build themselves a really complicated model on a very powerful computer. So they might model the core, they might model the atmosphere, and we use models like this here on Earth. One of the ways in which we use a model like that here on Earth is to predict the weather. And
cool.
What hurricanes are going to do, for example, or just what it's going to do tomorrow. Is it going to rain? Is it going to be sunny? Is it going to be windy? So all of that.
Oh, I never thought of it that way. Yeah, you're right. Okay, that's really neat.
All right. What was the other question? Do we have any?
Those were the two. You
Okay.
answered.
All right. I was going to show you where Uranus is located in the sky. So let's do that before we go and have a look at it in the telescope to finish up here. So I'm bringing up handy dandy Stellarium here. Let's see if I can get Stellarium. Well, let's see here. Zoom, are you going to let me screen share Stellarium? Yes, you are. Here we go. Now, let's go find, get rid of all this junk here. No, I'm not going to worry about it. Okay. Let's go find Uranus. So it's going to go point at Uranus, and I'm going to zoom out. So I'm also going to turn on the constellation lines here so you can kind of see where the constellations are. And let's turn on the labels too. So here's Orion right here. And then here is Mars. So this sort of reddish thing right here, this is Mars. Bill talked about Mars last week. Mars is right now in the sky, and if you go outside and you look up kind of high up in the southwest, you're going to see this reddish looking thing. That is Mars. Uranus is right next to Mars. Now I'm going to zoom up. Let's see if we can spot this. I'm going to zoom in a lot. And now you can see here's Mars and here's Uranus right here.
Now, how would you know that you are looking at Uranus in the night sky, like in your backyard? Is there a way to tell?
So Uranus is actually faint enough where we really can't see it without a telescope.
Oh, okay, okay.
So yeah, Uranus and Neptune, we really can't see without a telescope. Uranus is in theory bright enough. Well, let me see. Yeah, so Uranus is in theory bright enough to see with your eye, but you would have to be under an extremely dark sky. Like you'd have to be under the sky out in the middle of the desert or middle of the ocean. And you'd have to know exactly where to look.
Okay, I got you.
Really, for all practical purposes, we can't see Uranus without binoculars or a telescope.
Gotcha.
Yeah. Yeah, Uranus and Neptune are faint planets.
Well, I mean, they're a little far away.
Far away and all that. Okay, well, let's see if I can set up another view here from the telescope. All right, there we go. Let me make this bigger. Again, I have this this is our live view right here, which is where we couldn't see Uranus. So I'm going to circle my mouse around Uranus in the live view before we go take another picture and make it bigger. So if I'm circling my mouse around it, does anyone see that little, oh, go away, you red square. That is not in the sky, by the way. That's in our camera software. So if I'm circling my mouse around the little tiny dot, can anyone see that?
I cannot see it at all.
Yeah. All right. Live view, hard to see. Let's get out of live view. Okay. So I'm going to take a half-second exposure of Uranus here. So let's make that happen. Never like that view. I'm going to use this view right here. So again, this purple right here, I really can't tell if this purple blue is the planet or if this is actually an effect in the telescope. Our telescope will sometimes produce, especially around bright stars and planets, the sort of purple ring. It's the way the lens works. The fancy word for it is chromatic aberration. I can't tell if I'm seeing a little bit of chromatic aberration there or if that's actually on the planet. And this might be a long enough exposure on the camera that we're picking that little bit of stuff up from the telescope lens. Let's try now making a longer exposure. So close that out. Let's go to 1 second and then we'll go to 5 seconds just for fun. So now we actually held the shutter of the camera open for a full second there. Looks pretty similar, doesn't it?
Yeah, yeah.
Let's try 5 seconds and see how that looks. So
Now it does seem bigger before you switch to the saved image. It does look bigger in that small screen.
Yeah. So 5 seconds is probably going to look even bigger or a little bit bigger. So when I click shoot, the camera's going to hold its shutter open for a full 5 seconds. So.
Okay. And then Wesley is wondering he's saying chromatic aberration, question mark. So what do you mean by chromatic aberration?
Oh, let's see.
Oh, wait, Matthew, you could see some of the moons just then.
I'm wondering, I'm not sure if these are moons right here or if these are stars. That is a really good question. But yeah, this looks to me like chromatic aberration. So basically what happens is our telescope is a historic telescope. It was made in 1926. And its lens, and really lenses of many telescopes do this, especially your simpler lenses on smaller telescopes and also your lenses on older telescopes. they actually will focus different wavelengths of light in slightly different places. And the result of that is you'll get this color halo around a bright object. We usually see them around bright stars, like Betelgeuse, for example, or bright planets like Jupiter. But I think with our camera, we're actually picking up some of this around Uranus. So what it is basically an artifact of the telescope lens and the way it focuses the light. So yeah, I don't think that's the true color of Uranus there.
Gotcha. All right. All right. Well, did you have any closing remarks before we let everybody go for the night? I think we're starting to drop some numbers. I think folks are starting.
To the end here. I'm just gonna for fun take one of those 1/10 of a second exposures. Let's take a 25th of a second and just get see if we can get the natural color of the planet back, just as kind of a sort of wrap up here. There we go. So this is going to be the big view. There we go. Let's zoom it up. Now you can really kind of see that greenish, bluish color of the planet.
Yeah. Oh, that's beautiful. I like it. I like it.
There we go. We can actually see the true color of Uranus there with our telescope here in the middle of Columbia. Look what we can do.
I know, that's not too shabby for in the dead of the city, right?
That's right. Yeah.
Thank you so much, Mr. Matthew. I had fun tonight. I learned a lot. So thank you so much for sharing all of that really cool information with us. Again, thank you, Boeing, and thank you, members. We couldn't do this without you. And if anybody has any questions, just shoot us an email. And we're done for the night. So we hope to see everyone next week.
Thank you all so much, and we'll see you later. Stay safe out there.
Bye.
Bye.